Alright guys, today's essential question is, what effect does the degree and lead coefficient have on the end behavior of the graph of a polynomial function? Let's start off with what exactly a polynomial function is. So a polynomial function is where the degree is n and a is the coefficient, looks like this. F of x equals a naught x to the n plus a to the first x to the n minus 1 plus all the way blah blah blah. So for example, this would be an example of a polynomial function. 5x to the fourth minus 3x cubed plus 12x squared minus 7x plus 2. Notice that the exponents are nice whole numbers. There's no negative exponents. They're nice positive integers. And there's no square roots, no radicals, no absolute values. The degree of a polynomial is determined by the greatest exponent. So for example, the degree of the polynomial that I highlighted would be degree 4 because it is the highest, greatest exponent for that polynomial function. The degree of the function tells the maximum number of real zeros the function has, or the number of times the graph of the function crosses the x-axis. So for example, since this is a degree 4, that tells me that at most that graph would cross the x-axis 4 times. Or it also means that at most it has 4 complex roots or solutions. Now, a leading coefficient is the coefficient on the term of the highest degree. So for example, in the problem above, 5 would be my leading coefficient because that is the coefficient of the term of the highest degree. Now, the end behavior of a graph is what direction the graph is going on the left side or the right side. So, not really concerned about what's going on in the middle, just what's going on the left side and the right side. And so that gives us 4 possible scenarios. Either it's going up on the left and up on the right, or it's going down on the left, down on the right, or it's going up on the left, down on the right, or it's going down on the left and up on the right. The end behavior is what's it doing on either side, not really what's concerned about what's going on in the middle. Alright, now here are the rules for end behavior. You look at the degree and the leading coefficient. If the degree is even, then that means the end behavior are going to go in the same direction. So either both up or both down. If it's positive leading coefficient, they're both going to be going up. If it's a negative leading coefficient, they're both going to be going down. Now, if it's an odd degree, that means they're going to be going in different directions. If it's a positive leading coefficient and odd, it's going to go down on the left, up on the right. If it's a negative leading coefficient and odd degree, it's going to be going up on the left and down on the right. Now, the notation at the bottom is how we write it without using the symbols. So, for example, what this represents right here is as x approaches near infinity. Remember, x is the domain. Domain means left and right. So, if this says x goes to near infinity, this means to the left, and then as x goes positive infinity, that means to the right. So, on the left-hand side, the graph is going up. So that's why this says f of x is positive infinity. On the right-hand side, it's also going up. So that's why it says f of x is going to positive infinity. So the f of x part is the y value. The x part is the domain. And that's how we write it out using function notation. All right, let's take a look at 2 examples. So take a look at this first one. F of x equals 3x to the fourth plus 5x cubed plus 2x squared minus 3x minus 7. If I notice the degree of this polynomial is 4, my lead coefficient is 3. Well, my degree is even, which means that my end behavior is going to go in the same direction. My lead coefficient is 3. That's a positive, so that means that the end behavior is going to be both be going up. And so the way I would write this is as x goes to negative infinity, which means on the left-hand side, my function is going up, so going to positive infinity. As x goes to positive infinity, that means the right-hand side, my function is also going up, so it's positive infinity. All right, take a look at the second one. Even though it's written out of order, my degree for this polynomial is 5. My lead coefficient is -3. So my degree is odd, which means they're going to go in different directions, and my lead coefficient is negative, so that means it's going to be going up on the left and down on the right. So when I write this out, I'm going to say as x approaches negative infinity, which means on the left, my function is going up, so it's going to go to positive infinity. As x goes to positive infinity, that means on the right-hand side, my function is going down, so I'm going to put negative infinity, f of x approaches negative infinity. All right, let's take a look at one more. For this function, my degree is 3. My lead coefficient is an understood 1. My degree is odd, so that means it's going to go in different directions. My lead coefficient is positive, so that means it's going to be going down on the left, up on the right. So if I write this out, as x approaches negative infinity, which means on the left, my function is going down, so it's going to go to negative infinity. As x approaches positive infinity, which means on the right, my function is going up, so it's going to go to positive infinity. Now if I go back, it said determine the maximum number of x-intercepts each function can have. Well, that's clearly easy. It's just simply 3. Remember, the degree of the polynomial tells you the maximum number of x-intercepts or complex roots that you'll have for that function. All right, that's it for today's lesson.